Saxon's Trig, lesson 101, continuing, and we were only partway through B when B and C kind of combined, when I ended up having to stop. So what we had gotten through was determining that x was a 3 and each of the denominators was negative 11. And so now we are continuing to pull to get the tops for the y and the z. And if you were remembering, then that formula was coming from here. So our next one is going to be our x's, answers, then z's. So for the x's, it was 2, 1, 3. For the answers, 7, -2, 16. And then the z's, 2, -1, and 2. And then we're repeating the first two columns, 2, 1, and 3, 7, -2, and 16. Then 2 times -2 is -4, times 2 is -8. And that's Florida, don't change the sign. 7, -1, -7 times 3, -21. Again, Florida, don't change the sign. And then 2, 1, and 16. So 2 times 16 is 32. Don't change the sign. Then 3, -2, and 6. So -6, -12, change the sign. 16, -1, and 2, -16, -32, change the sign. 2, 1, and 7, 14, change it to -14. And before I continued, I was just trying to check those numbers. -8, -21, 32, 12, 32, and the -14. Correct. Okay, so then this combined is going to give us 33 over that same -11. I guess I could put it in both places. So that's going to be y equals -3. Now we're going to do our z. And again, that pattern was x's, y's, answers. So our x's are 2, 1, and 3. Y's are 1, 1, -1, and answers 7, -2, and 16. Then we're going to repeat those first two rows, 2, 1, 3, 1, 1, -1. Now 2, 1, and 16, 32, don't change the sign. 1, -2, 3, so that's -6, don't change the sign. 7, 1, and -1, -7, don't change the sign. 3, 1, and 7, 21, but do change the sign because it went to Canada. -1, -2, 2, that's 2, 4, so change the sign, -4. And 16 times the ones is 16, but change the sign. And now that gives us, just checking, no problems with those errors, signs. Okay, so that's going to be -22 over the -11. So that gives us z equals 2. So now we have the 3 answers. The final step is to, because this was a system of equations in the original, we are going to write it as a coordinate point, although it's a 3 coordinate point, but it's still x, y, then z. So it's 3, -3, and 2 for the answer for that problem. All right, let's do example 2. This time, thankfully, it only asks us to solve for the z. So in the equations, we are given 3x plus 2y plus z equals 9, 2y plus 3z equals 14. Now notice that that one didn't have all 3, but that's okay. I'll show you here. You're going to fill in for the missings, equals 3. So here are our 3 equations that we're being given. So I have an x for this one and this one, but not for this one. So for this one, there is an implied 0x because it didn't exist. I have a y, and a y, no problem. I have a z, and a oops, no z. So this one is going to imply a 0z is with this one. So when I do my denominator, we are dealing with x's, so 3, 0, and 1. Then y's, 2, 2, and 2, and z's 1, 3, and 0. And then for, because we're doing, wait, not y, z. I think that sounded right. We are solving for z. So z equals, and then the top for the z, oh, that is totally going to be in the way, is our x's. So 3, 0, 1. Our y's, 2, 2, and 2, not our z's at all. And then our answers, 9, 14, and 3. Okay, so usually I do the denominator first, but that's because I'm going to repeat it, so it doesn't really matter. We're just going to do 3, 0, 1, 2, 2, 2, 9, 14, and 3. Repeat the first two rows, 3, 0, and 1, 2, 2, and 2. Now, because of the zeros, I know that life is going to be a little bit easier because I'm going to have a bunch of answers that are actually 0. So not this one. 2, 18, negative 18, Canada. 2, 14, and 3, 28 times 3, 84, negative 84. And then 3, 0, and 2 is a 0, so I don't even need to worry about it. Then 3, 2, and 3, 9 times 2 is 18, don't change the sign. 2, 14, and 1, that's 28, don't change the sign. 9, 0, and 2 is a 0, don't need it. So for the numerator, we should have negative 18, the negative 84, 18, and the 28. So that is negative 56. And now our denominator, I need to rewrite so we can repeat. And then 3, 0, 1, 2, 2, and 2. All right, so 3, 2, and 0, don't need it. 2 times 3 is 6, no change on sign. Okay, there's a 0 in that one, so I don't need it. 1, 2, and 1 is 2, change the sign because I went to Canada. 9 and 2, 18, change the sign. Zeros don't matter. So my denominator number will be negative 14. Let me double check. 18, 19, 20. Yes. And then two negatives make a positive. So z equals positive. And how many times does 14 go into 56? 4 times. So you see how this is just another method other than substitution or elimination, but it also gives me the option to solve for a specific letter without having to go through potentially solving for the other ones. Now, part D is independent equations, and I did say at the beginning of the other video that this is very brief. So we know that independent equations are ones in which our answers can stand alone. Such as if x is 2, then the y is 1 perhaps, so that's making the coordinate point 2, 1. But what happens when I do a determinant for the denominator and I discover that I have a 0? Well, we've already said we can't do that. If all three determinants would give me a 0 in the denominator, then I know that this is not an independent equation. They would be dependent. In other words, they would probably be identical when they were all reduced. And so therefore they are not independent equations if the denominators are all spitting out, not just the denominators, if the determinant is spitting out a 0. So it would be more, those would be undefined. It would be your zeros in the numerator for all three of them, giving you your answers for all three determinants are 0. Then it is a dependent equation, not an independent one.